हेलो, गुड आफ्टरनून। अंकिता, बाकी सबका क्या खबर है जो अभी तक ज्वाइन नहीं किए?
सर हम टेक्स्ट कर दिए हैं, सब ज्वाइन कर रहे हैं सर।
Okay, let's start. Transducer part is the last part is the capacitive transducer, which is the variable capacitance of the transducer. The principle of the variable capacitance is used in displacement measuring transduction in various way, and capacitance is a function of effective area. Capacitance is a function of effective area of conductor, and the separation between the conductor and the dielectric strength of the material. It is described in the equation below, which is C equals to epsilon A D, which where the C is the capacitance, where epsilon is the dielectric constant and the of the dielectric medium, and A is the area of the electrode, and D is the distance between two parallel electrodes. So the equation for measuring the capacitance by using transducer by the method of variable capacitance transducer is that C equals to epsilon A of D, and here is the this is two is the electrode, and this distance is the D, and this is the dielectric material, and this is the A, area of the electrode. This is the area of the electrode both, and the working principle is depends on the changing of the capacitance or variable capacitance or the changing the, so change the dielectric constant and change with the position of the two electrode, are change in area and changing is distance between the electrode plate, and the changing of the material between the electrode, thus the permeability is also changes. So now the working principle is that there are three ways to change in capacitance. First of all, this epsilon A or D, it's depend on the any one of which change, then the capacitance also change. So the three way to change the capacitance, and the changing in area, changing in distance between the electrode plate, and the changing of the material between the electrode, thus the permittivity of the change. The epsilon is the depends or change according to the material. So if the material is changed, so the epsilon also changes. So capacitance can be changes according to these three parameter. First one is the epsilon, second one is the A area, and the last one is the D. So dielectric constant, area of the electrode, and the distance between two parallel electrode. So now this is our two two plate. One is fixed plate, both are metal, and another is movable. And this is our displacement. And these two plate, there will be a air dielectric. There is a air dielectric. And another picture you see here, one is fixed plate or fixed metal plate, another is movable plate, and this is our displacement. And the dielectric medium is the solid, is here acting as a dielectric medium. Solid here acting as a dielectric medium. So one of the two electrode is made fixed and another is made of movable for measurement of displacement. And the displacement to be measured is applied to movable plate. As the plate moves, the distance between the plate is increased, and thus the change of capacitance is measurement. जो डिस्प्लेसमेंट हमको मेजर करना है वो हम लोग इसको अप्लाई करेंगे. तो अगर अप्लाई करेंगे तो फिक्स प्लेट जो है वो मेरा चेंजेस नहीं होगा, वो तो फिक्स्ड ही रहेगा. बट जो मूवेबल प्लेट वो मूव करेगा. जब मूव करेगा जब द डिस्टेंस बिटवीन टू प्लेट इज भी चेंजेस. So अगर distance between two plate अगर change होगा, then the capacitance also change. By so we can measure the changing the distance between the plate. It's increases, then the change of capacitance is measured. And the changes of capacitance will be function of displacement of the electrode. The changing or the change of thus the change in the capacitance will be function of the displacement of the electrode. So डिस्प्लेसमेंट के अकॉर्डिंग मेरा कैपेसिटेंस भी चेंज करेगा. क्यों कैपेसिटेंस चेंज करेगा? क्योंकि जब डिस्प्लेसमेंट इज अप्लाइड ऑनटू द दिस मटेरियल, मींस वन इज फिक्स मेटल, अनदर इज मूवेबल मेटल. तो मूवेबल मेटल अगर मूव करेगा तो डिस्टेंस बिटवीन टू प्लेट अगर इंक्रीज कर जाएगा, तो इंक्रीज करेगा तो क्या होगा उसका, due to this increasing the capacitance also change. So this changing of the capacitance we can measure the displacement. Okay, so another is the concentric hollow metal cylinder. Here the on is and this is the fixed and this is our movable cylinder. If the capacitor plates are formed by two concentric hollow and metal cylinder, the displacement to be measured is applied the inner cylinder. This is our inner cylinder, or our displacement which is to be measured is applied in this portion, and show that this can be movable and which change the capacitance. Just for example of transducer, just capacitance transducer for level measurement. By using capacitor transducer, we can measure the level. So this is the metal vessel, and this is vapor, and this is the dielectric constant or dielectric sheet, and this is our liquid. This is our liquid, and this is a probe. This is a probe, and this is our this is the another one terminal. This is another terminal. Here the both electrode are fixed, so the distance is constant. क्योंकि ये मेरा मेटल वेसल है, तो ये तो चेंज इसका जो एरिया है लेंथ है वो कुछ भी चेंज नहीं होगा. तो यहाँ पर जो कैपेसिटेंस मतलब changing of the distance between two plate, it not be possible because here both are fixed. So here change of the dielectric material or dielectric constant. So we can measure the displacement measure the level of the any liquid. So how it can be worked? Here the both electrode are fixed, so the distance is constant. On electrode is dipped into the liquid and another on fixed of the wall tank. This is the fixed, and this is our on the electrode is in a liquid. One is fixed and another is poured into the liquid. So one electrode is dipped into the liquid and another one is fixed on the wall of the tank. as the liquid level is increased, so the permittivity is a change, thus the capacitance is changes. अगर लिक्विड लेवल इंक्रीज करेगा तो क्या होगा मेरा ऑन तो फिक्स्ड है टर्म इलेक्ट्रोड, अनदर इज deep in a liquid, and on another is in a wall of the tank, so the change of the liquid level, it's the change, it's the permittivity. So changing by the permittivity, the capacitance also change. So by changing the permittivity and change the capacitance, we can measure or by the level of the liquid by using this type of method. So it is produce a accuracy and advantage. So it produce an accurate frequency response to the both static and dynamic measurement. And another is that the loading effect is negligible. And drawback or disadvantage is that the accuracy can be affected by change in temperature. अगर लिक्विड का टेम्परेचर अगर चेंज होगा तो उसका एक्यूरेसी जो है वो उसमें इफेक्ट हो सकता है, क्योंकि अगर टेम्परेचर हाई होगा तब क्या होगा, उसका परमिटिविटी अकॉर्डिंग टू ऊपर इसके ऊपर डिपेंड करता है। सो टेम्परेचर के ऊपर उसका लेवल व जो ये है मतलब परमिटिविटी वो भी चेंज थोड़ा होगा, तो उसके कारण जो एक्यूरेट रीडिंग को नहीं मिलता है। सो इट इज कैन की disadvantage is that in this method the accuracy can be affected by change in temperature of the any liquid or any parameter under measurement. And due to the terminal, this to the terminal port, the so here is the another effect is lead effect. As the lead is lengthy, it can be causes the error or distortion in the signal. This is the due to the lead effect is occurs in this measurement technique. So another measurement technique of this transducer is that magnetoresistive transducer. Magnetoresistive transducer can be explained as a corresponding change in length per unit length produced as a result of magnetization. The material should be magnetoresistive in nature, मतलब जो मटेरियल यूज करना है वो हमको मैग्नेटोस्टिक इन नेचर होना है, and this phenomena is known as a magnetoresistic effect, and the effect can be resolved in the sense that if the external force is applied on a magnetoresistic material, there will be a proportional change in magnetic state of the material, and the property was first discovered by James Prescott Joule by noticing the change in length of the material according to the change of magnetization, and he called the phenomena as a Joule effect, and the reverse process is called Valery effect or the magnetoresistic effect. Means that reverse process means that due to the change in length of material according to change in magnetization, up to the change in magnetization, so length also changes. So reverse process is this, the change in magnetization, the length also change of the material. So this reverse process is called Valery effect or the magnetoresistic effect, and this effect explained in the change in magnetization of the material due to the force applied, and Joule effect is commonly applied in magnetoresistic actuator, or Valery effect is applied in a magnetoresistic sensor, and this process is highly applicable as a transducer as a magnetoresistic property of material does not degrade within the time. So magnetoresistic transducer is a device which used to convert the mechanical energy into magnetic energy, which is used as a mechanical energy to into magnetic energy, and the vice versa. Such device can be used as a sensor, and also actuation as a transducer. Its characteristic is very high due to the bidirectional coupling between the mechanical and the magnetic state in material. So इसमें क्या होता है एक्चुअली मैग्नेटिक ट्रांसड्यूसर में क्या होता है, इट्स कन्वर्ट द मैकेनिकल एनर्जी, क्योंकि ड्यू टू द चेंज ऑफ लेंथ the magnetization also change. So due to the magnetization change, the mechanical energy is converted into magnetic energy. And another thing, if the reverse or Valery effect is that what happened due to the magnetization changes or the magnetization changes, the length also changes. So here the magnetic energy is converted into mechanical displacement or mechanical energy, and such device can be used as a sensor, and also it's got used as a transducer. Characteristic is very high due to the bidirectional coupling between the mechanical and magnetic state of the material. And this device can be also called a electromagneto-mechanical device, as an electrical conversion to its appropriate mechanical energy done by device itself. And in other device, this operation carried out by passing a current into a wire conductor, so the production or produce of a magnetic field, or measuring current induced by a magnetic field to sense the magnetic field strength, to sense the magnetic field strength. And the working principle is that here the figure below describes the exact working of the magnetic transducer. The difference figure explains the amount of strain produced from null magnetization to full magnetization. Here the figure shows the different type of working of the magnetic transducer, and the different figure explain the amount of strain produced from null magnetization to full magnetization. At, at a condition, there will be a null magnetization, but due to the magnetization and the full magnetization, it will be, you see here Sn, but in this case here Ns, here Ns, and here the B is changing, showing the magnetization due to the strain, the change in magnetization. Initial position, this is Sn, but after applying strain, it will be changed from Sn. So here see the figure, they are changing properties, and then again it's applying the more magnetization, or show full due to the towards the full magnetization. The final magnetization, the graph is, the diagram is shown here, shown here. The for first considering the case, there will be no magnetic field is applied into the material. In figure A, there will be a no magnetic field is applied to the material, but this shown in figure C, and thus the change in length is also the null along the magnetic induction product produced, and the amount of magnetic field H is increased to its saturation limit, or plus Hs or H sat, and this causes the increase of axial strain to ESAT and ASAT, and also there will be an increase in value of the magnetization to value of B sat in figure E, means this figure, and the maximum strain, saturation, and magnetic induction is obtained at the point when the value of Hs is at its maximum. And at this point, even we try to increase the value of field, and it will bring any change of value of the magnetization or the field to the device. And thus when the field value its saturation, then the value of strain and magnetic induction will be increased and moving from center figure to upward or outward direction. And another is that let us consider the another instance where the value of Hs is kept fixed. At the same time, if we increase the amount of force or magnetic material, the compressive stress is in the material will increase on the opposite side along with a reduction in value of axial strain and axial magnetization. And in figure C, there are a no flux line present due to the null magnetization. And figure B and D has the magnetic flux line in much lesser magnitude, but according to the alignment of the magnetic domain in the magnetic driver, it also figure A also has flux line in the same design, but its flow will be opposite direction. And the F shows the flux line according to the applied field Hs and the placing of the magnetic domain. And the flux field produced are measured using principle of Hall effect or by calculating the voltage produced in a conductor kept as a right angle of the flux produced. The flux field produced are measured using principle of Hall effect or by calculating the voltage produced in conductor, and it is kept in right angle to the flux produces, and this value will be proportional to the input strain or the force. And the application of this type of transducer is that there are two effects. One is the Joule effect, another is the Villari effect. In the case where the magnetic energy converted into mechanical energy, it can be used for producing a force in case of the actuator, and can be used the dielectric magnetic field in the case of sensor. And if the mechanical energy is converted into magnetic energy, it can be used for detecting force or motion. And another is that it is early days this device was used in application like a torque meter, sonar scanning device, and hydrophone, telephone receiver, and so on. Nowadays, with the invent of giant through or the magnetic alloy, it being used as a making device like a high force linear motor or position for the adaptive of optics active the during active variation or the noise control system, and the medical and industrial ultrasonic and also pump or so on. And the ultrasonic magnetic transducer have developed for making a surgical tool or underwater sonar and the chemical and metal processing. Okay, so application is that it can be used as a development of for making the surgical tools and underwater sonar and chemical and material processing industries. Just 1 second. And another transducer is the piezoelectric transducer. So what happened in actually in piezoelectric transducer is that a transducer can be anything which convert one form of energy to another form. This is called transducer, which can be convert one form of energy to another form of energy. So piezoelectric material is one kind of transducer which sequence the material or we apply the force or pressure on the material, it convert into a electrical voltage or electric voltage, or this voltage is a function of force or applied pressure. So piezoelectric material में क्या होता है, due to the applying force or pressure, the material convert its into the electrical voltage, and this voltage is caused or the function of force or pressure which is applied on the this piezoelectric material or piezoelectric crystal. So the electric the the material which behaves such as way is known as a piezoelectric sensor. The material which behaves in such a way is known as a piezoelectric sensor, and the electric voltage produced by piezoelectric transducer can be easily measured by voltage measuring instrument, and which can be the used to measure a stress or forces, and the physical quantity like the mechanical stress or the force cannot be measured directly. So therefore we can use the piezoelectric transducer can be measuring this type of physical quantity, stress or force. Okay, so electric or piezoelectric transducer can be easily measured by the voltage by measuring instrument of which produced by piezoelectric material, and which can be used to measure the stress or force. But in generally क्या होता है, there will be no such a technique to measure the physical stress or force. So the physical quantity like mechanical stress or force cannot be measured directly. So therefore, how can be measured? It applied on the piezoelectric material and which produced a voltage, and this voltage is the function of the applied force or stress upon the that material. Okay, so we can easily measure indirectly by using piezoelectric transducer, measure the stress or force. Okay, so this is the piezoelectric effect. Here is the stress is applied on this piezoelectric material. So there will be a meter is connected, which from where we can show the voltage or produced voltage which is produced by the piezoelectric material, and when the stress or the force is applied on this material. So piezoelectric, another thing is that piezoelectric actuator. So piezoelectric actuator behaves as a reverse manner of piezoelectric sensor. मतलब piezoelectric actuator क्या करते हैं? तो ये reverse rules follow करते हैं of piezoelectric sensor, means that it's on which the electric effect will cause the material to deform and such stretch or blend, and this means in that piezoelectric sensor, when the force is applied to the stretch or bend it, an electric potential is generated, and the opposite in opposite when the electric actuator or the or a electric potential is applied, so it deforms or stretch or bend. Okay, so piezoelectric actuator actually behaves on the opposite or reverse manner of the normal जो electrical or normal जो piezoelectric sensor है, and 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 it is on which the electric effect will be cause the material to deform and is that stretch or bend, and that means the piezoelectric sensor when the force is applied to a stretch or bend it, the electric potential is generated, and the opposite when the piezoelectric when a piezoelectric actuator and the electric potential is applied it is deformed is that blend stretch or blend. So this is the piezoelectric material. This is the deformation due to the voltage applied on the piezoelectric material. So or this type of piezoelectric material, this type of sensor is called is a इनवर्स पीजोइलेक्ट्रिक इफेक्ट। बिकॉज इनवर्स पीजोइलेक्ट्रिक इफेक्ट क्यों बोलते हैं? क्योंकि इन जनरल क्या होता है, इन जनरल क्या होता है, हम लोग जब कोई फोर्स व स्ट्रेस अप्लाई करते हैं पीजोइलेक्ट्रिक क्रिस्टल में तो वो एक पोटेंशियल डिफरेंस प्रोड्यूस करता है, मतलब वोल्टेज प्रोड्यूस करता है। क्योंकि प्रोड्यूस क्यों करता है? क्योंकि एक्सटर्नल फोर्स और स्ट्रेस व प्रेशर जब अप्लाई करते हैं तभी होते हैं। बट इसमें क्या हो रहा है, हम लोग जब पीजोइलेक्ट्रिक क्रिस्टल मटेरियल में एक सप्लाई वोल्टेज दे रहा है, तब क्या होता है उसका जो स्ट्रक्चर है उसको चेंज करते हैं, मतलब ऐसे ही वो चेंज होता है और डिफॉर्मेशन होता है। तो ड्यू टू दिस डिफॉर्मेशन, the deformation due to this deformation, this is called inverse piezoelectric effect. This is called inverse piezoelectric effect. So piezoelectric transducer consists of a quartz crystal. Piezoelectric transducer consists of a quartz crystal which is made from silicon and oxygen arranged in crystalline structure. Silicon oxygen in a crystalline structure, which is SiO2, and generally unit cell of the basic repeating unit is that all of the crystal is symmetrical, but the piezoelectric quartz crystal is not. Actually, what happened in piezoelectric crystal are electrically neutral, and the atoms inside and the atom inside them may not be symmetrically arranged, but their electrical changes are balanced, means that positive charges cancel out negative charge. And the quartz crystal has a unique property of generating electrical polarity when mechanical stress applied on it along with a certain plane. And basically there are two types of stress. One is compressive stress and another is tensile stress. So generally two stress were acting. First one is the compressive stress and second one is the tensile stress. So compressive stress is that the stretched, and this is the tensile strength. So change in, this is the for positive change is included induced in the other way and change induced in the one way. So this is called compressive stress and this is called tensile stress. And when there is a unstressed quartz, no change induced, no change induced on it. In case of compressive stress, positive charges are induced in a on side and negative charge induced in the opposite side, and the crystal size gets a thinner and longer due to the compressive stress. In case of tensile stress, the change in induced reverse as a compared to the compressive stress, and the quartz crystal gets a shorter and faster. And the piezoelectric crystal is based on principle of piezoelectric effect. So piezoelectric transducer is based on the principle of piezoelectric effect. The word piezoelectric is derived from the Greek word piezoon, and which means the sequence or the press. And the piezoelectric effect state that when mechanical stress or force is applied on the quartz crystal and produced electrical charge on quartz crystal surface, produce a electrical charge on a quartz crystal surface. And the piezoelectric effect is discovered by Perry and Jacobs Curie. Perry and Jacobs Curie, and the rate of change of produced, the rate of charge, the rate of charge produced will be proportional to the rate of change of the mechanical stress mechanical stress applied on it, and will be higher will be stress and higher will be stress and higher will be voltage. अगर stress higher होगा तो voltage भी मेरा high होगा. And one of the unique characteristic of the piezoelectric effect is that it is the reversible, means when voltage is applied to them, they tends to change the dimension of the certain plane or the quartz crystal structure is placed into the electric field, and it is deformed the quartz crystal by amount of proportional to the strength of electric field. And it the same structure is placed in the electric field with the direction of the field reversed, and due to the deformation it will be opposite. So this is the working principle of the piezoelectric transducer, and the quartz crystal becomes shorter due to the electric field applied in reverse direction. If the self-generating transducer, if it is it is a self-generating transducer and it does not require electric voltage source for operation, and the electric voltage produced by the piezoelectric transducer is linearly varies to the applied stress or the force, and the piezoelectric transducer has a high sensitivity, so it acts as a sensor and it is also used in a accelerometer due to the excellent frequency response. It is also act as a sensor and also it is used as a accelerometer due to the excellent frequency response. And the piezoelectric effect is used in many applications involved in production and detection of the sound and electronic frequency generation, and it acts as an ignition source and secret lighter, and it is also used in sonar, microphone, force or pressure and displacement measurement. Just some example of the some application of the piezoelectric material. First one is that in microphone sound pressure is converted into electric signal, and this signal is ultimately applied to produce a louder sound. तो माइक्रोफोन में क्या होता है, the sound pressure which is converted into a electric signal, and this signal is ultimately amplified to produce the louder sound. Another example is that, or application is that, automobile seat belt lock in response to a rapid declaration, and it is also done by using piezoelectric material. So ऑटोमोबाइल में जो सीट बेल्ट रहता है, अगर वो जब 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 कोई आदमी बैठता है तो क्या होता है उसका, ड्यू टू द फोर्स द के अंदर ड्यू टू द फोर्स इट कैन बी प्रोड्यूस ए साउंड, क्योंकि क्यों साउंड प्रोड्यूस करते हैं, ड्यू टू द अप्लाइड फोर्स, there will be applied force, the change in the material, if the voltage will be changed. So this change in voltage, it indicates that you lock the seat belt. And another example is that it is also used in medical diagnostics, and also it is used in fertility treatment. It is also used in fertility treatment. So these two are the basic transducer part. Only the first one is the capacitive transducer and second one is the piezoelectric transducer. So I covered all the part of the transducer part, which is inductive transducer, capacitive transducer, resistive transducer, and finally the thermistor, piezoelectric transducer, and all the part. If any of query or any kind of doubt, so please ask me the question. Hello.
सर वो सीट बेल्ट वाला बताइए फिर से।
हेलो।
हेलो
हाँ बोलो।
सर वो सीट बेल्ट वाला बताइए फिर से, वो समझ में नहीं आया।
एक्चुअली सीट बेल्ट में क्या होता है, जब हम लोग गाड़ी का जो सामने सीट में बैठते हैं, कोई भी ड्राइवर मतलब ड्राइवर सीट में बैठते हैं, तब क्या होता है उसके अंदर जो सेंसर रहता है वो एक्चुअली पीजोइलेक्ट्रिक टाइप ऑफ मटेरियल सेंसर। तो उसमें क्या होता है, जब फोर्स देते हैं तो ड्यू टू द फोर्स क्या होता है, जो पीजोइलेक्ट्रिक मटेरियल रहते हैं तो क्या होता है उसका वो वोल्टेज प्रोड्यूस करता है, क्योंकि जब फोर्स बा प्रेशर देंगे तभी क्या होता है वो मटेरियल क्या करते हैं, पोटेंशियल डिफरेंस और वोल्टेज प्रोड्यूस करते हैं। तो उस वोल्टेज किसका फंक्शन होता है, उस फोर्स बा प्रेशर का। तो वो तब क्या होता है, वो फोर्स और प्रेशर जब ही होता है, देखो जब सीट में हम लोग बैठते हैं तभी वो जो सीट बेल्ट का आवाज देता है। क्यों आवाज देता है, क्योंकि फोर्स वो पीजोइलेक्ट्रिक क्रिस्टल के ऊपर पड़ा है, तो वो क्या हुआ है उसका, वो ड्यू टू द फोर्स और प्रेशर क्या होता है, वो वोल्टेज प्रोड्यूस्ड होता है। दिस वोल्टेज विल बी indicate that you lock the seat belt. After locking the seat belt, the signal is optimizes. मतलब प्रेशर होता है ना, जब बैठते हैं तब तो प्रेशर हो रहा है, क्योंकि अगर हम अंदर मतलब मेरे जब सीट में बैठते हैं तब उसके अगर पीजोइलेक्ट्रिक क्रिस्टल मटेरियल होता है तो क्या होता है कि वो तो ड्यू टू द प्रेशर वो वोल्टेज प्रोड्यूस करते हैं। जो मेन जो ये है मेरा फंडा है जो पीजोइलेक्ट्रिक क्रिस्टल का, ये जो क्या होता है एक्चुअली दिस मटेरियल कन्वर्ट द इलेक्ट्रिकल वोल्टेज। तो इसमें क्या होता है फोर्स व प्रेशर एंड इज कन्वर्ट इनटू ए इलेक्ट्रिक वोल्टेज एंड दिस वोल्टेज किसका फंक्शन होता है फोर्स व प्रेशर। तो तभी क्या होता है उसके साथ साउंड ये साउंड सेंसर रहते, मतलब वो जो पीजोइलेक्ट्रिक सेंसर है वो आउटपुट वोल्टेज देता है, तब वो क्या होता है वो इंडिकेट करता है जो सीट बेल्ट लॉक नहीं किया। जब सीट बेल्ट लॉक करते हैं तब क्या होता है उसको उस सिग्नल को ऑप्टिमाइज किया जाता है, मतलब एलिमिनेट किया जाता है तभी, और वो सिग्नल नहीं देता है। ठीक है,
यस सर।
ओके, एंड करते हैं आज के क्लास।